Sir.
So, welcome to the last problem solving session for the course of geotechnical engineering. Just a minute, I will share my screen. Is my
झालं
screen visible
चालवलंय.
now?
Yes, sir, it's
Yes, sir.
visible.
Okay. So, uh, welcome to the final session. Last week, that is 12th week of the problem solving session for the course Geotechnical Engineering 1, uh, handled by Professor D.N. Singh of Department of Civil Engineering, IIT Bombay. And I am Yogendra Narayanan. I am a PMRF research scholar who has been conducting these sessions for the entire course. So since these recordings go to the public forum, I will just um, give a brief preview of the reason for this session and what we will be doing in this session. So these sessions are essentially designed to make the learners proficient in the contents that has been covered in a particular week by solving previous assignments and other problems related to the concepts that has been taught in the a particular week of that course. And these sessions have been held on Saturdays from 5 p.m. to 7 p.m. And each course, and it is the uh, last session of this series. So uh, uh, the problems that are being discussed in these sessions would be uh, helpful in approaching the problems that will be asked in several examinations. So with this preview, I will just uh, I'll just uh, give an outline of the contents that has been covered in the last uh, concepts that has been covered in this week, that is week 12. So essentially, this session started with the Terzaghi's one-dimensional consolidation theory and the derivation, the partial differential equation governing it, and the constant, which is the coefficient of consolidation, and the various methods of obtaining it from laboratory data, and solution of those equations which yielded the result of time factor and the drainage boundary, and followed by uh, uh, degree of consolidation, some concepts on degree of consolidation and their dependencies, and how to obtain the degree of consolidation, and how to obtain the time factor. And from this 1D consolidation, there has been a transition to three-dimensional consolidation, which is PVDs, pre-vertical drains, and sand drains, and partially these concepts are also used in the stone columns. So, and the governing laws and some basics of stone columns, how the PVDs are spaced and how their spacings are calculated, and how the rate of consolidation, that is the rate of settlement or rate of consolidation, changes by taking into account the radial and vertical consolidations. So with this a background of the contents, we'll be solving some of the problems. Mostly the questions will be concentrated on one-dimensional theory, uh, and we'll be starting with some of the conceptual questions, followed by some of the numericals, which will be from little easy to difficult. The difficulty level will gradually increase. So I hope let us start this one. So in a soil sample of a consolidometer test, pore water pressure is option A minimum at the center, option B maximum at the top, C maximum at the center, D minimum at the bottom. Maximum at the bottom.
Maximum at the center.
Another person, any other guesses? Okay. So why it is maximum at the center? Because what will happen is that, let us consider this is the soil sample which is in the oedometer ring. What is the thickness of oedometer ring? General thickness
0.25.
will be 2 centimeters and dia will be 6 centimeters. So hence D to H ratio will be 3 is to 1. So this is the standard oedometer ring. So do not forget it will be 3 is to 1 ratio, and generally the thickness will be 2 centimeters. And if they give any questions regarding oedometer ring and they did not give any sample thickness, then you can assume that it is 2 centimeter and solve the problem. So now what will happen is that, let us consider two drainage conditions. First is double drainage. Let us take this as a reference line. So what will be the pore pressure at both if it is a double drainage condition? You have knowledge about single drainage and double drainage, right? Uh, it has been taught in the course in this week. You know that? Please respond. Hello.
Yes, sir.
So you have idea about single drainage and double drainage, right?
Yes, sir.
Okay. So if it is a double drainage condition, what will be the, let us consider this as point A and the middle as point B and this as point C. If it is a double drainage condition, what will be the pore pressure at A?
0.
0. And at C?
0.
So it will slowly, gradually increase like this and it will attain 0. So this is the middle. This is at the, it will be maximum at the middle. Now, if it is a single drainage condition, what will happen? Let us say this is only the drainage condition. This is impermeable.
Maximum at the bottom at that time.
It will be maximum at the bottom.
Yes, sir.
So hence here, based on, since this question does not have any conditions on drainage problem, default you can take it as double drainage and you can write it as maximum at the center. And generally these problems, these type of questions will have uh, the nature of the drainage conditions, and if it is not given you can consider it as double drainage,
Ye-
right? So coming to the second question, log of time method is suitable for which type of soils? Log of time method. Log of time method is used to determine what parameter? So
Yes, sir.
log of time method is used to find what parameter?
Fine grain soils with very low permeability, I think.
No, no. Please listen to my question. Log of time method is used to calculate which parameter?
Which parameter?
For calculating what you will use log of time?
PV.
Log of time. The other person will to determine which parameter.
Coefficient of consolidation.
Yes, it is CV. To determine CV, we use one is logarithm or log of time method. Second one is, which is the second method? One is log of time. Second
Square root method.
is square root method. Will be square root of t method. This is log
So
of t.
screen is not visible.
Okay, just a minute. Is it visible now?
Yes, sir.
So it will be square root of time method. Now, so consolidation, we know that it may take for years, right or wrong?
Yes, sir.
So now, as you said, the log of time method is usually used for fine grained soil with low permeability. That is the right answer. But why? Why it is used?
Because of fine grain soils, it will take uh, more time for the consolidation.
More time. Then why you can use square root also, right?
Yes, sir.
Why we are not using? Why we will use, but why it is advisable to use log of t?
Because log of t is the accurate value.
Log of t, generally what will happen? We will plot the dial gauge readings with square root of t, dial gauge readings, or log of t, right? Now,
Yes, sir.
I want you to do one exercise. So we know that for, let us take fine grained soils with very low permeability, right?
Yes,
Now,
sir.
what I want you to do is, let us take, it takes almost 2 years to attain 90% consolidation. Okay. Now
Yes, sir.
you convert 2 years into minutes and take its square root and logarithm and tell me the value.
Okay, sir.
How much we are getting? 2 years, 24 months.
7.79 in logs.
Okay. In square root,
Root.
how much we are getting in square root? No need to tell the exact value, just say approximately.
7,941.
Yes. So if you take square root of t, you are getting 7,000 something,
Yes,
7,900
sir.
something. When you are taking log t, you are
700.
getting 7.79,
9.
right?
Something.
Now we
Mm.
know that fine grain soils having very low permeability will take lot of time. So when you plot, when you have to accommodate a very larger time in a relatively shorter graph, we always prefer logarithm,
Logarithmic.
logarithmic scale. That is why, if you remember, in particle size distribution graph, we have particle size ranging from microns to millimeters to centimeters. So it is in the scale of
Mm.
10 power minus 6, 10 power minus 3, 10 power minus 2 meters. So it is in a very larger scale, thousands of scales, right?
Okay, sir.
So that is why when we are plotting it in a logarithmic scale curve. This is percentage finer and this is diameter in logarithmic scale. The same way we are utilizing when you have a very large range of values, we always prefer logarithmic time, right? So that is the reason, that is one of the reasons why we use logarithm of time method for fine grained soils with very low permeability. Hope it is clear now.
Yes, sir.
Any confusions?
No, sir.
Now let us move to the next question. So here we have a graph here. Are you able to see the graph?
Yes, sir.
So there are some portions indicated. So now based on the graph, I would like you to answer these two questions. The portion of the graph representing OC behavior is
OC. BC.
yes, okay. Any other any, any other part which is representing OC?
Mm. No, sir.
The other person, any different opinions or different views?
No, sir.
Okay. Now, as you said, this is the over consolidated behavior, but in the unloading direction. Why it becomes over consolidated behavior from this point itself is the moment you unload it and you reload it, it will be like this, right? right
Yes,
or
sir.
wrong? When you load it, see,
Yes, sir.
from the point D you are starting, you are loading it up to point B, you are unloading it, and you are reloading it. So this entire portion, the soil will be behaving as a OC. Now, what is this point B?
Virgin AD and AB.
No, no. What is this point B? Point B known as, for this cycle of loading,
Pre-consolidation point.
yes, it is pre-consolidation pressure. Sigma dash pre-consolidation pressure. Now, coming to the second part of the question, the portion of the graph representing virgin compression behavior is,
Virgin
which is,
compression behavior. AB.
yes, it is AB.
AB.
So this part
Okay.
is initial compression, which is which includes some readjustment in the, how to say, in the um, some removal of air and some minimal compression, and followed by it will be a virgin compression zone. So this will be virgin NC behavior, and this is OC, and this portion, if it is extended,
Sir, what is AD?
AD. AD is the initial compression. Just the moment you apply load, if the soil is, even though soil is saturated, there will be some air present. So the moment you apply the load, that air might escape, and that causes small a compression which is uh, insignificant. That is very less in magnitude. And once from point A, it starts showing its virgin consolidation behavior,
Okay.
virgin compression
Okay,
behavior.
sir.
And once you unload it, that is from point B to C, and reload it from point C to B, here I am just extending the situation as like this. Now, what will be this zone known as?
This is also virgin compression current.
It is a virgin compression zone or NC zone, normal consolidated behavior. So now, now again you are reloading it, unloading it, and reloading it. Now, what is this point known as? This is the
Pre-consolidation.
new pre-consolidation pressure.
Okay.
Right now, this is the new pre-consolidation pressure. So, like this, cycles of loading will be taking taking place over a due course of time. So, generally, this pre-consolidation behavior, we conduct some tests, and we come to know the pre-consolidation pressure for that particular state of material. Right. So from the formation of soils, the soil might undergo several of these cycles, and it reaches at a particular pre-consolidation pressure. So the present pre-consolidation pressure only we will be able to find out from oedometer tests. All right.
Okay, sir. Okay, sir.
So coming to the next question, PVDs are installed in ground to what? To do what?
What is meaning of PVD, sir?
Pre-vertical drains, prefabricated vertical drains, or sand drains. We use in three-dimensional consolidation, right? 3D consolidation.
Increases the rate of consolidation.
Yes, that is increases or decreases.
Increases, sir.
Okay. If rate of consolidation is increased, what will happen?
Re- de- um, the decreases the time of the consolidation.
Yes, decreases the time of consolidation. So now increase the rate of consolidation in the sense time is getting decreased, right?
Yes, sir.
Now let us consider this relation. TV is equal to CV T by D square. Now rate of consolidation increases, means time is decreasing. Now one more possibility is CV also can increase or decrease.
Increases.
So
Increases.
CV also will increase. There is a possibility for CV to increase also. So then what will be the answer here?
Increases the coefficient of consolidation also. B and C. The A
Both
and C.
both A and C. So this is the right option. Any doubts?
No, sir.
Is it clear now?
Yes, sir.
So coming to this question first, now you do the match the following. We have three parameters: coefficient of compressibility, compression index, coefficient of consolidation. So and list 2 gives the method of obtaining it. Now you can match the respective question in list 1 to list 2. What is coefficient of compressibility?
Coefficient of compressibility AB.
It is AB. Compression index
Stress versus
is,
wide ratio.
yes, it is stress versus,
Stress versus wide ratio.
that is E versus sigma dash.
Sigma.
And compression index is denoted
Compression
by
index of log stress to void ratio. CC.
this CC.
CC.
So it is log stress to void ratio E log sigma dash, E versus log sigma dash. And coefficient of consolidation is obviously dial gauge reading with
Dial gauge reading vice versa time.
time. Time can be either log of time or root of time.
Okay, sir.
And um, coming to the question at the right, instrument used for calculating the coefficient of radial consolidation is
Radial consolidation.
radial consolidation is 3D, 3D
Triaxial.
consolidation.
Triaxial.
Uh, no,
Okay.
Odometers.
Oh, Rosas cell. Rose cells. Okay.
why not odometer?
Radial. In odometer test, the radial is 0. Mhm.
In triaxial,
In triaxial, I don't the idea properly, sir. I forgot.
yeah, it is rho SL only, radial consolidation. Odometer listen carefully. Oedometer ring, we will not allow the soil sample. The radial strain will be zero, which we have discussed in last week, like last week session. The strain will be zero. The soil will not be either allowed or allowed to expand or compress in the radial direction. Oedometer ring is only for single dimension consolidation, 1D consolidation. So in row cell, we have facility for 3D consolidation. And apart from oedometer, 1D consolidation can also be performed by triaxial tests. So triaxial test will not be covered here. This is just for your understanding. 1D consolidation behavior can be studied both by using oedometer test and triaxial tests. Triaxial test will be covered in the next course, Geotechnical Engineering 2.
Okay.
So if I take that session, then we will see that. So it is for see, 3D consolidation or radial consolidation or the utilizations of prefabricated vertical drains or sand drains. So everything's are conceptually, all concepts are same. That is, for practicing this, to implement this in field, you have to understand this. All right. So don't get confused by what is radial, what is 3D, PVD, sand drains, and etc.
Okay, sir.
All right. So now we can move to the next question. So here, the settlement analysis for a clay layer draining from top and bottom shows a settlement of 2.5 centimeter in 4 years and an ultimate settlement of 15 centimeter. However, detailed drainage subsurface investigation reveals that there is no drainage at the bottom. Now, for this condition, the ultimate settlement will be. Any guesses? Are you able to understand
Time
that question? Are you able to understand the question or not?
Yes, sir, understood.
How will you calculate this? This is a tricky question, so think carefully and say.
The settlement and this total drainage total years.
Any idea?
Sir, the settlement is 15 centimeters, sir.
Ultimate settlement.
Ultimate settlement is 15 centimeters. But the time years is different.
Why?
ultimate in clay layer or any layer, the ultimate settlement is same. But if double drainage system, the S is the S is reduced. Single drainage, the S is increased.
Yes. So, any contradiction to this view? Any other explanations? Yeah. So, yes, anything, anyone wants to say anything? So, first, let me make it clear. This is the ultimate settlement, right? So, yeah, let me make it clear. So, the entire concept of consolidation, is that is, it has two components, right? Listen carefully. This might be a good revision for you. So, consolidation has essentially two components, which is magnitude of settlement, right? That is how, what is that? Delta H. Second one is time, that is rate at which delta H is achieved, right? These are two important components. So now if you take this part, it is essentially a function of void ratio and sigma dash. And this is essentially a function of permeability and volume compressibility, right? And time. Permeability, if we take permeability into account, it obviously brings in the drainage condition also. Now, the magnitude of settlement, this does not depend on the time. So, whatever be the time, either it will be 10 years or 15 years or 20 years or 25 years, it is eventually it is going to attain a settlement of, let us say, 15 centimeters. That's all. So, how much ever you play with the permeability, compressibility, or drainage conditions of the soils, the ultimate thickness or ultimate settlement will not change. And The component linking the settlement to the time is MV, because MV will be relating delta E by E plus E into
1 plus E.
delta sigma dash. So this will be present in both the how much settlement will take place and rate of settlement at which what settlement occurs. That also this compressibility will govern. Volume compressibility will govern. Other than that, the magnitude of ultimate settlement will not change. So it is purely porous media dependent characteristics or soil characteristic, and rate is the hydraulic characteristic. Right? Please do not forget this. The question might be twisted. Several times in gate examinations also they have asked this type of trickier questions. If somebody has given gate, they might have an idea. So this is one of the uh, trickiest part of the one of the trickier part you might be tested. So with this, let us move to the next question. Hope it is clear. Any doubts?
No, sir,
Yeah,
it's
sir,
clear.
it's clear.
Okay. Now the second and third questions are fairly simple. You can try the second question. If the drainage length doubles, the time for consolidation, 50% consolidation. What will happen if drainage doubles? What will happen to the time?
Decreases. So 50% is got to the length doubles. Drainage is equal to H by 2
Okay.
T.
So now let us solve it systematically. We know that TV is equal to CV T by D square, right? T is equal to TV D square by CV. Now what we are doing is we are just changing the drainage layer. We are not touching any consolidation TV or CV. The rate of the degree of consolidation remains same, that is 50%, right? So if you put D square, it is for single drainage condition. For double drainage condition, let us take it is T1. Now for double drainage condition, not double drainage, here the drainage length is doubled.
So
Listen
D is equal
carefully. T2 is equal to TV into 2D whole square by CV. Now T2 is equal to 4 times TV D square by CV. T2 is equal to 4 T1. What is happening? Time is decreasing or increasing?
time is increasing.
Then you said time will decrease.
I thought double drainage, not double the length.
So you have to read the question carefully, right? So double drainage length doubles is it is changing from a double drainage to single drainage. That is the one of the analogies. that is happening. Our thickness of clay layer is increased. That also may be one of the analogies. So any uh, conditions may prevail. Now, third question is fairly simple, straightforward. Time factor for 40% consolidation for a saturated clay layer is. What is the relation you will use here?
uh, pi by 4 into u whole square.
PV is equal to
Pi by 4 into
pi by 4 into U by
100
100. U will be in
whole square
percentage
percentage.
whole square.
Whole square.
Now calculate this and say and let me know the answer.
Zero point 0.1256.
So 0.4 square into pi divided by 3. How much you are getting?
0.1256.
1, 2.
Yes.
Yes, your will be 0.1256
0.1256.
or 57. If you round it up, it will be 57. So not an issue. If you express in 3 digits, it will be 0.126.
156.
So this is the relationship and this is the value. Now moving to the next question. A 10-meter clay layer is sandwiched between two sand layers and subjected to a uniformly distributed load of 100 kPa. The coefficient of consolidation is 0.005 centimeter square per second. What is the length of the drainage path? First question. Second question is, for that drainage condition, what will be the time required for 50% consolidation? And the third question is, what is the time required for 90% consolidation? How will you approach this question? Let us go by question by question. So what is the answer for the first question? What is the length of drainage path?
The length of drainage path is 10,
10.
but clay layer is 10. No. Oh, no, no, sir. The length of the drainage
Now
path.
listen here. Whenever you approach a problem regarding consolidation or effective stresses or
Okay,
uh,
5.
will be 5. So just for a general suggestion, whenever you come across a problem on consolidation and effective stresses and flow, always draw the given condition. So maybe this is the ground level and this is the clay layer, clay. This is sand. This is sand. So this is 10 meters. Now it is subjected to 100 kPa load. Right, this is the conceptual figure. And clay we have CV value is given, some value. Right. Now, what is the length of the drainage path? So drainage path, to calculate the length of the drainage path, we have to know what type of drainage it is. What type
Double
of drainage
drains.
it is? It is double drainage. So if it is double
Drains.
drainage, D is equal to
H by
H by
H by 2.
2. Will be 10 by 2 is 5 meters. Right. Now, coming to the second part of the question, time required for 50% consolidation. So, how can we write T? T is equal to TV D square by CV. Right?
Yes, sir.
Here, what we know, what we don't know.
Time factor is don't know. So we find time factor.
How will we find time factor?
Time factor is pi by 4 into
TV is equal to pi by 4 into
zero point
U
0.5
by
whole square.
100 whole square. Now, how much you are getting here?
0 0.196.
0.196.
1.
The other person, are you getting these answers?
Yes, sir, getting.
Okay. So now you substitute here and you know D, you know CV, calculate time. Make sure the units are same. See here it is centimeter square and this is in meters. So we can convert either meters to centimeters or centimeters to meters. I will prefer to go with centimeters to meters. So it will be 0.196 into
9.8 per
9,
seconds.
9.8.
Oh, sorry. Sorry, sir.
I told you to take care of the units.
Seconds. Okay.
So it will be 5 square 25,000 5 into 10 power minus 3. You will get 1.96 into 5 into 10 power 4 into 10 power 3. You will get approximately 0.196. 0.2 into 5, you will get approximately 1 into 10 power 7. You get 0.98 into 10 power 7 or 9.8 into 10 power 6 seconds. If you convert into days,
113 days.
yes, it is 113 days, which is approximately how many months? 3.9 months, or then round it up to 4 months. Similar way, can you calculate for question number C? What will be the change here for question number C?
Time factor will be changed.
Okay, now you substitute the time factor formula the uh, time factor formula for 90% consolidation and calculate the t value.
Time factor formula.
Time factor will be 1.781 minus 0.933 log of 100 minus u in percentage. How much you are getting time factor?
0.848.
Yes, exact 0.848. Time will be 0.848 into 5 into 10 power 7. 0.85 into 8, 0, 4.4. See, 4.24 into 10 to the power 7. How much days you are getting?
490.
Yes, it will be 4. How much? 490?
490.7.
It is approximately 491 days. So always look for the degree of consolidation. Based on that, use the TV relationship, and always look for the what type of drainage and what is the drainage path that you have to take. Always you have to be very careful on choosing these two values, and obviously unit conversions. And in the examination, questions will be asked such that you will be asked to report your answers in a particular unit. So be careful of those. Either you might be solving in kg per centimeter square, and they might be asking in kilonewton per meter square. So you might have to change the you might have to convert the units and report your answers. So these are the some of the smaller things that you may need to take care of. And moving on to the next question. Now it is one of the practical problems. So how we translate the laboratory test to the field. So the question reads as follows. An oedometer test is performed on a 2 centimeter thick clay sample. After 5 minutes, 50% consolidation is reached. After how long a time will the same degree of consolidation be achieved in the field where the clay layer is 3.70 meter thick? Assume the sample and the clay layer have the same drainage boundary conditions. Can you solve this question? So you have to calculate. So we know that PV is equal to CV T by T square. Now for both, first let us consider for lab. CV into will be 5 minutes T square will be, let us consider single drainage condition. First you do since first you do it with double drainage. Double
We
drainage
take the
means,
double drainage, sir.
so by default you can take the double drainage. Will be 1 square. Now CV will not change. So CV and TV will not change. So we can write it as TV by CV1 is equal to, that is lab, TV by CV in field. So that will be T by D square in lab is equal to T by D square in field. So 5 minutes by 1 square is equal to T by 370 by 2. T is equal to 5 into 185. How much you are getting?
3,422.5 minutes.
3000.
Yes, sir, because you gave the 3.7 meters and 2 centimeter.
I told you to do with single double drainage, na?
Yes, sir, double drainage I take.
Double drainage will be 1 centimeter and 370 by 2. Okay, whole
Not
square, na?
5.
Yes, yes, yes. Now it will be square of it. How much you are getting?
3,422 minutes.
Check the values once. It is in square.
47 hours.
Yeah. 47 hours.
Yes, sir.
It is in square. T by D square. So you have to convert this 3.70 into centimeters. This is 2 centimeters.
Sir, 185 square. Huh?
It has to be, na?
ఇవన్నీ ఒకటి వచ్చింది.
Double drainage condition.
Yes, sir.
Double drainage is 370 by 2, which is 180 into 2, it is 360. 185 into 2, it is 370. It is in squares.
So 171125 seconds.
17
1125 seconds.
seconds or minutes?
Seconds, sir.
5 is minutes.
5 is minutes, sir.
Yes, in question it is minutes, na?
Ah, yes, sir. Minutes, sir.
So convert into months or number of months.
So number of
Months.
3.9.
60
3.9 months.
will be approximately 3.9 months.
Approximately 4 months.
4 months. So what is the laboratory test doing? It is saving your time. So you can estimate if you know these parameters, you can estimate what will be the estimated time of settlement or consolidation in field. So here, for just an extra information, why we apply this is, in some cases, before the start of construction, we do a thing called preloading. So preloading is we place a heavy load over the area of construction such that the before the start of actual construction, the complete consolidation settlement has taken place. So the time for which the preload has to be kept over the particular soil layer will be determined by converting the laboratory test into field test in a similar manner. So that is how in the real life it is being used, right?
Yes, sir.
Now moving to the next question. So the time for clay layer to achieve 85% consolidation is 10 years. If the layer was half as thick, 10 times more permeable, and 4 times more compressible, then the time required to achieve the same degree of consolidation is. How will you do it? Any idea?
No, sir. Explain.
Okay. Now you have to find time. Now what is given for the first condition? Percentage is given, 10 years is given. Now, since the degree of consolidation and time is given, obviously we have to use this formula, right? Now, this 85% for both the cases is going to remain the same, right? So, TV will be same. So, CV1 T1 by D1 square is equal to CV2 T2 by D2 square. Understood? Please respond.
Yes, sir.
Now, what they have given is, let us consider for simplicity single drainage condition, right? So that we don't need to divide the do again divide the layer by 2 and everything. So let it be single drainage condition, or you can try it with double drainage also, no issues. Now the first condition is layer was half as thick, that is D2 is equal to how much? D1
By 2.
D1 by 2. Second part is 10 times more permeable. K2 is 10 times K1 and more compressible. MV2 is 4 MV
Why
1.
take MV? Sir,
Understood? Yes.
meaning MV meaning is compressible, sir. Volume
It is
compressibility or compressible
volume
is
compressibility, na?
okay.
So there is a reason why we took MV. You have an idea about T1, T2. T2 is the thing you need to find out. You know D1 and D2. How will you calculate CV and CV2? CV is equal to
K
K
into
by
MV K by MV
MV
into
into,
gamma W.
is it right? No, no, no.
K into K into కదా.
Yes, yes, yes. Right, right, right. It is right. So K by MV into gamma W. Right. Now let us substitute here. K1
4
T1 divided by MV1 gamma W D1 square is equal to K2 T2 MV2 gamma W into D2 square. So this and this can be cancelled. So it will be K1 T1 divided by MV1 D1 square. Now you substitute all the conditions here. K2 is 10, K1, T2 is what you need to find out. MV2 is 4 MV1 into D2 is now you can cancel K1 K1 MV1 MV1 D1 square D1 square 4 and 4. Now T1 is equal to 10 T2. T2 is equal to T1 by 10. T2 is equal to 10 by
8
10 in 1 year. Right? Understood?
yes, sir.
Any doubts?
No, sir.
If you have any doubts, feel free to interrupt me. So, more than understanding the problem, you have to understand how to approach the problem. So based on the given details, we have to understand what they are asking and what we can do with the given details. So in the similar way, can you calculate for this question? What is the ratio of permeabilities Ka by Kb of two specimens of clay A and B with following properties? How will you do it? Cv is equal to K by Mb gamma W. K is equal to Cv Mb gamma W. Now Ka by Kb equal to Cv is 3.8 into 10 to the power minus 4. Mb is 3.6 into 10 to the power minus 4 divided by 1.9 into 10 to the power minus 4 into 3.8 10 to the power minus 4. Now you can see here I did not take into account the values, that is the conversion values. These are in meter square and these are in centimeter square. I did not take into account because obviously numerator and denominator will get cancelled. So similar way, this also will get cancelled. Eventually we will get 3.8 into 3.6 by 1.9 into 3.8. So this will get cancelled. How much will be getting? 1 point?
1.89.
Yes, 1.89. Right?
Sir, 3.R or 1.8
Which one?
at the
Oh,
denominator?
okay. MBB is 1.8, na? Sorry.
Answer is 4.
It will be 4. So this will be 2 times. This will be 2 times. It will be 4. Sorry. Thank you for correcting. Understood? Let us move to the next question. What would be the average degree of consolidation if the vertical and radial consolidation are 20% and 70% respectively?
I don't have any idea.
So average degree
I
of
don't.
consolidation is given by 1 minus 1 minus u of vertical into 1 minus u of radial. It will be 1
In
minus,
percentage or points, U.
if it is if it will be in decimal. Since it is 1, you have to do it in decimal. If it is in percentage, it will be 100 minus 100 minus u into 100 minus u. That will not be possible because this will be higher value. So usually it will be in decimals only. Right. 1 minus vertical is 0.2, horizontal is 0.7.
Zero 0.76.
It will be how much? 0.8 into 0.3, 0.24, it will be 0.76. Average
76.
degree will be 76%. Right. Now, this is coefficient of consolidation in vertical direction. Right. CV is equal to KV by MV in vertical direction into gamma W. Now, in a similar way, coefficient of consolidation in radial direction is given by CR. This is KR or KH. MV or gamma W. Now, listen carefully. Let me give you a condition that MV H or R is equal to MV vertical. Right. Now, relationship between CV and CR will be what will be the relationship between CV and CR? Any idea? Any idea?
Replace above MVR value in the.
No, I gave a condition that MVR is equal to MV. Now, if you want to derive a relationship between CV and CR, relationship between means whether it is equal to or greater than or less than.
Okay.
It depends on
CV greater than CR.
how. Now here you have to use your earlier knowledge. Now you can see that since MV, the denominator are same for both the condition, the relationship depends on K. CV is directly proportional to K or KV, and coefficient of consolidation is directly proportional. What is the relationship between KH and KV?
KH greater than KV.
KH is greater than KV. Hence, what will be the relation between CV and CR? Which will be greater?
CV is greater than okay. CR is greater than CV.
CR is greater than CV generally. It is a general condition. Right.
CV opposite होता
Right. Now, moving to the next question. What will be the effective radius of the influence zone made by prefabricated vertical drains arranged in square patterns of side length 1.5 meter? Now listen this question. There are two types of arrangement of pre-vertical drains. One is triangular. Another one is square. Okay. Understood? Now this is the center to center distance. This is known as spacing, and similarly this is known as spacing. This is known as spacing. Center to center distances are known as spacings. Now square pattern of side length 1.5 meter. So they have given indirectly spacing as 1.5 meters. So the effective radius of influence zone is denoted by RE. RE is equal to 0.525. Yes. RE is equal to 0.565. Yes. So 525 for triangular arrangement. This is for square. Now, since we have asked for square, we will be calculating 0.565 into 1.5. How much you are getting?
Point 84.
Will be 0.84 something approximately. Understood? So this you need to remember for triangle and squares. Right? Now let us do this problem. So doing this problem you will come to get a fairly good idea about consolidation theory. After solving this problem, if some time is left, we will solve the next question, or otherwise you can go through the slides and try it on your own. So now look at this question. A 3-meter thick layer beneath a building is overlain by a permeable stratum and is underlain by an impervious rock. The coefficient of consolidation of this clay is 0.025 centimeter square per minute, and the ultimate settlement for the layer is 8 centimeters, and they have given corresponding TV value. They have given TV values for corresponding U. So the first question will be, how much time in years will it take for 80% of the total settlement to occur? So I will be solving this question. Uh, Carefully listen and please respond whenever I stop and ask you question. So, and if you have any doubts, you can ask. So, coming to the first question, how much time will it take for 80% of the total settlement to occur? So, now what is the data we have? First, always draw the figure. There is a building here, there is a clay layer, this is impervious, and this is sand or pervious layer, right? Now the thickness is 3 meters. So what is the type of drainage here?
Single drainage.
So it is single drainage. So D will be how much?
H, H,
H is what?
3.
3 meters, right? And we have CV. CV is equal to some 0.025 centimeter square per minute. Yes. Any doubts? Any doubts?
No,
No,
sir.
sir.
Now, what we need? We need time. Time is equal to PV d square by CV. So now we need TV. TV we have U and TV we have a table. Now you need to find U. So U is 0.8. So for 0.8, what is the TV?
0.567.
So substitute here 0.567. D will be 300 square divided by 0.025. Calculate this and tell me the answer. So it will be 560.
2041
Sorry,
200
convert it into years.
Centimeters.
3.393, sir.
Okay, be 3.94
93
years.
years.
0.03.
The other person, did you get the answer?
For 1 minute.
So it will be 3.94 years. All right. Now, coming to the next question, determine the time in days required for 2.5 centimeter settlement to occur. Now, same question, you know,
Sir,
yes,
okay, sir.
you need to find
Done.
TV. How will you find TV? For finding TV, you need U. How will you find U? U is total settlement by settlement at a particular time. How much it will be?
0.31.
It will be 0.3125.
ఇంకా అర్థం కావట్లేదు.
So approximately you can take the value for 0.3. So it will be
Oh, okay, sir.
0.071 into d square is 90,000 divided by 0.025. How much you will be getting?
One double 7.5 days. Sir,
Yes, yes, you are right. You are right. 177.5 days. So that will be approximately 178 days. Right. And third question is a back calculation. So T is equal to, or you can write as TV, you can come from the formula CV T by D square. Now what will happen is, you know T now, 6 months. That I think you need to convert into minutes. since CV is in minutes. So T you should convert into minutes, D you know, you have to calculate TV, and from TV value you can take the closest value of U, and U is equal to sum X divided by 8. So X is the amount of settlement that has taken place. So if you calculate 0.025 into 6 into 30 into 24 into 60 divided by 4. This you can cancel, this you can cancel. This will be 300, this will be 50, this will be 25, this can cancel, point 0 0 1.
Okay.
6 into 12 into point 0.072. So that will be 0.3. X by 8. X is equal to 2.4 centimeters. Right. This is well. Now you can see here. See, in the last question you got 178 days. It is approximately 6 months. Now, if you are clever enough, you can directly write it as here approximately 2.5. So some 2 days are there, you can write it as 2.47 or something. That is also approximately right. You can avoid calculations also. This is common sense. Right? Understood?
Yes, sir.
Are you getting the answers or not?
Yes, sir. Getting.
Okay. Now we will cover the last question also, since some time is there. So following specifications are given for a clay specimen of 20 mm height placed in a oidometer. So you can see here it is 2 centimeters. And for a particular sigma V1 150 kPa and E1 is 1.3, and for when it is increased by 150 kPa, E2 is that is the void ratio is getting decreased to 1.18. Now what they are saying is this is for 50% consolidation, or sorry. So you have total of 2 centimeters. Now you calculate what will be the settlement for 50% consolidation. For that you need to find capital H, right? How will you find out? CC by 1 plus E naught H log of sigma dash plus delta sigma dash by sigma dash, right? Let me do one thing. I will just give an outline of how to solve the problem. You can try it yourself, and if you have any doubts, you can place the questions in your doubt section, or ask a question section. So since we are running out of time, so now you will get delta H. Now you know that some small delta H by delta H is equal to U. Now U is 50%, 0.5 into delta H, you will get at 50% consolidation, right? Now next question is, they have given time for 50%, which is 20 minutes. Now what you need to find out is PV is equal to CV T by D square. Now you can consider double drainage. Usually in oedometer we will be considering double drainage only. So double drainage. So you can substitute the values. PV you can obtain from pi by 4 U by 100 square. Now from that you can obtain CV value, right? T you know, D square you know, PV you know from this value, right? CV value you will be obtaining. That CV you will be relating it to K by MV gamma W. Now you will be calculating this value. You have calculated time factor, you have calculated CV. Now you need to calculate K. For that you need MV. MV we know delta E by 1 plus E naught into 1 by delta sigma dash. So delta E, you can subtract this. 1 plus E naught is this. This is E naught. And delta sigma dash is this minus this, which is 150 kilopascal. So now we'll be getting MV. Gamma W you know 9.81 or 10 kilonewton per meter cube. CV you know you will be getting from here, and from that you can calculate K. Right? So you can try this question yourself. It is fairly some connections of some parameters which we have seen today. Are you able to follow the procedure? Or
Yes, sir. Yes, sir.
okay, you can try this question. So that is all for today's session. So I think the next week you
Sir.
are having exams, right?
Yes,
Yes,
sir.
sir.
So prepare well for the exams. All the best.
Thank you, sir. Sir,
So
exam pattern.
that we don't know. I
Uh,
don't know about the exam, but
Sir, in
you can expect
assignment,
similar questions. But
sir, I have a doubt, sir.
yes, tell me.
In assignment 11, in
Mm-hmm.
assignment, I think 11 or 10,
Mm-hmm.
the because the problem solutions is there, but not only answers, not the solutions. Yeah,
Okay.
already raised the question, but no reply, sir. In assignment 10, question number 3, stress distribution, I think,
Solutions.
are
Uh,
not provided in the assignment.
okay. That I think now we cannot change it. Maybe uh, solutions might be only key answers. I think are uploaded this time. So right now
Yes,
that we cannot change it now. So let me see.
only okay, sir.
Uh,
Because only the question, in case the solution is there, so how when I am the mistake, I know
okay. This
because I didn't understand
okay.
when I.
I understand this. So, but since uh, let me see. If anything can be done, we will be doing it. Don't worry.
Okay, sir.
Okay. So thank you for the sessions
Thank
and
you, sir.
all the best
Thank
for
you,
your
sir.
exams.
Thank you, sir.
Thank you, sir.
Thank you. You can leave the